Here's a good example of an ANOVA. And so that's what we're doing here. And ANOVA stands for um, analysis of variance. Okay. So how much do the means vary? Listed below are the amounts of arsenic in samples of brown rice from three different states. The amounts are in micrograms of arsenic, and all samples have the same serving size. So that's nice. Same serving size. That way everything's on an even playing field. Use a zero point zero 0.05 significance level to test the claim that the three samples are from populations with the same mean. Okay, so we're going into hypothesis test mode. All right. And with a hypothesis test, you're always testing, are the means the same? Or a little more information would be like back in previous section, we saw, oh yeah, we can compare two means. Are they the same? Are they not? ANOVA is for when you are testing three or more means, if they are all the same. So for that, that means that we are saying that the mean for Arkansas equals the mean for California equals the mean for Texas. So the null hypothesis is always for ANOVA going to be the means are all the same. Now, for the alternative hypothesis, it's not terribly complicated, but you do have to be slightly careful. Okay, you can't just say, "Oh, well, they're not all equal." No, no, no. Basically, you would say something like at least one of the means listed in the null hypothesis, at least one of the means is different. So it could be that these two are the same and this one's different. Or it could be that these two are the same and this one's different. Or it could be that these two are the same and this one's different. Or it could be that all three are different. Okay. So we're trying to say all of that in the alternative hypothesis. So that's why I'm saying at least one of the means is different from the others. Okay. So um, so that's where we're headed. Okay, now it's time to put the data into the calculator. Okay, so I'm going to pause for just one moment. So what I'm going to do is I'm going to go to stat, enter, and I'm going to put all the data from one of them. I'll just do them in the order they appear in the problem. All the data for one of them in L1. So Arkansas is going to go in L1, and I'll keep going. And then all of California in L2, all of Texas in L3. Okay, so all the data is in there. And as you can see, well, you can see just about all of it. The last one or two you can't, but that's okay. And then, so now that the data is in there, we're going to go to stat, over, jump to ANOVA. It's the last one on the list. And notice this one has parentheses saying, hey, give me all the lists. So I'm going to go blue 1 to get L1, comma, separate them with commas. Blue 2, comma, blue 3, and I don't think, and then I'll close it off. I don't think there's ever more than 3 lists in any of these problems. There might be. If there is, you just have an L4, but that's kind of it. Enter, and then it gives us a lot of information here. The main thing we're looking for is that p-value. Okay, so the p-value is not 5.6. I mean, it can't be more than 1. So hopefully, you are noticing the scientific notation. So the p-value is 0.120000006. Okay. This and the 6 rounds the 5 off, rounds it up. Okay. And clearly that's smaller than alpha, whatever alpha is, 0.05. Okay. So, because when the P is low, the null must go. Okay, so we have sufficient evidence. So we could say at the 0.05 level of significance, or significance level, there is sufficient evidence to reject the claim that the mean arsenic level in brown rice is the same for rice grown in Arkansas, California, and Texas. Okay, it's just not the same amount. All right. So we got that. Um, Now the follow-up questions. Okay, so do the amounts of arsenic to be appear to be different in the different states? Yes. Okay, they do appear to be different. Okay, because the means are not the same. All right, then we get into a more subtle question. Given that the amounts of arsenic in the samples from Texas have the highest mean, so if you went out and found the mean of each of the three, samples, you would find that the sample mean for Texas would be the biggest. Okay, whatever. Um, let's see. So, given that the amounts of arsenic in the samples from Texas have the highest mean, can we conclude that brown rice from Texas poses the greatest health problem? Okay, feel free to pause this to think about it. Okay, you had a chance to pause. So the answer is no. Okay, based on what we have done, based on our evidence, the answer, well, but based on what we've done, the answer is no. Okay, because remember when I was explaining what the alternative hypothesis means, it means that hey, maybe these are the same and this is different. Okay, or these are the same and this is different. Or these are the same, this is different. Or they're just all different from each other. We don't know. Okay. All we know is at least one of the means is different. Okay. Probably Texas. But this test doesn't tell us that. We would have to do something different next to make that conclusion. Okay. So that's what the ANOVA tells us. Hey, at least one of these is different. Which one? We don't know. It doesn't say. Just at least one is different from the others. Now, that's what the author says. I would go even further. Again, when it says, can we conclude that brown rice in Texas poses the greatest health problem? Well, I would say no for another reason as well, although the author's reason was quite good. I would say, well, I misspelled greatest. Okay, whoops. Um, I would say, well, health problems can occur from more than just arsenic, although that certainly can be a contributing factor. You get enough of it in you, it is poisonous or deadly. But there are other things that could be going on with the rice that might make Arkansas or California cause bigger health problems. Okay. And this study here definitely does not examine anything other than arsenic, but there could be other things as well. Okay. So again, when you conduct a hypothesis test, you have to stick to what it says. Okay? You have to stick to what it says, what information it actually gives, and not make something up, because that's very common to do. I've done it too.